In this video, we'll be discussing the loading data in R. In previous notebooks and videos, we demonstrated how you can load datasets that come with R and its packages, but we have not yet discussed how you can load your own data. In the first section here, we're going to take a look at 3 ways that you can read a file containing tabular or rectangular data. However, each of these methods is going to be relatively low level. There are packages that provide additional functionality for importing and loading data. For example, the Reader and Read Excel packages, which are part of Tidyverse, are linked here, and they provide functions for several common formats, including Excel files. In R, when loading data, it is generally assumed that it's already coming in some sort of reasonable format. And that doesn't mean that more complicated parsing of input data can't be performed. It just means that sometimes it's better to use tools external to R to prepare your data in advance before trying to load it in R. So the first function we're going to look at is the Readlines function. This function reads n lines from a file, where the lines in the file are defined by or separated by new line characters. And the number of lines to be read is actually specified as an argument n. If we don't know the number of lines in a file, and we really want to read the entire file, then we can actually pass -1 as the value of n. So the Readlines function will read every line in the input file. Of course, in order to use this function to read from a file, we actually need a file. So we're going to create a temporary file, write some data into it, and then we're going to use this temporary file to demonstrate the Readlines function. So to create our temporary file, we need a name. And since I don't want to accidentally overwrite something in your system, we're going to use a handy function tempFile, which generates a random file name for us. And the tempFile function takes several arguments, but for our purposes here, we're only going to specify the file extension, which we want to be .data. And now to actually write data to this file, I'm going to use the cat function. So I will paste in a line of code. And you see that our cat function is being given several strings. The first string that is given, this is our header, is going to represent the header for our data file. So typically in a data file, a header would contain information describing where or how the data was collected. But for this example, we're simply going to use the string, this is our header. Now for the remaining lines, notice that these are nicely formatted values separated by commas, and we're including both row and column labels. So we have R1, R2, and R3 in the first column. Those are our row labels. And in the top row of this, we have A, B, C, and D as our column labels. Now, if you recall from our previous examples with the cat function, this writes to the console by default. If we specify the file argument to be the name of our temporary file, then the cat function will actually write these strings to the file and not to the console. In addition, the separator argument here, SEP, we're specifying to be the new line character. So when the cat function writes these strings to our file, it's going to use a new line to separate each of them. And this is important since we're going to demonstrate the Readlines function, and the Readlines function uses the new line character as the delimiter between the lines when it's reading. Now at this point, if we had run the code block, our temporary file would have our table data in it, and we would be ready to actually load that data back using the Readlines function. So the Readlines function is going to return a character vector, where each element in the vector is one line from our file. So let's create a variable lines and assign to it the character vector that's returned by readlines. Now again, readlines requires a file name in order to know where to read from, and then it also needs to be told how many lines to read, and so we're going to be using -1 to tell it to read the entire file. And now after this, the lines variable should contain all the lines in our file. Since we're done reading our file, and this was a temporary file to begin with, I don't want to leave it laying around on the system. To actually clean up our mess a little bit, we can use the unlink function to remove our temporary file. And now let's just print out the lines so that we can actually see what the Readlines function returns. Now the output here shows that first, we did actually read the file. And second, it shows that our lines variable is a character vector where each element is a line from the file. So we have 5 strings contained within this character vector. Now, unfortunately, all of our data is currently in string form, right? We have a matrix of numeric values, but it's not stored as a matrix. And so if you wanted to use this method to read your files, you would then have to parse each of these strings, of course, knowing something about the format, since one of the strings is a header, another string contains column labels, and the first part of each of the remaining strings contains row labels. So the format needs to be known, and you would have to parse each of these strings to pull out the numeric data. Now that's beyond the scope of what we want to discuss here, but one way for you to do this is to use the string split function from the stringer package, which is part of tidyverse. But since this is beyond the scope we want to discuss here, let me show you an easier way. The read table family of functions all read tabular data or rectangular data and will return that data as a data frame with more appropriately typed columns than the character vector that we just received from readlines. The functions in this family really only differ in their default values. And so because of that, we're just going to look at the read.table function. And I'm going to specify only the arguments we actually need to read the data from our temporary file. And if we look at the help page for read.table, we'll see that there are actually a lot of arguments that we're not going to address. So I do encourage you to check out this help page and read about each of them. So let's start again with our temporary file. This is going to be the exact same data that was in our readlines example. And so I'm just going to copy and paste this again. And now to load this temporary file into a data frame, we call read.table and pass our temporary file name. And then for the remainder of the arguments, we're going to describe the format of the file. So the values we give to the arguments of read table are actually going to be driven by the organization or the format of our data file. So the first thing we're going to tell read.table is that our data file contains one line of text that is not data. And this is our file header, which is the first line here stating this is our header. And we tell the read table function to skip this using the skip argument. And we're going to give it the value 1, indicating that there's only one line to be skipped. Next, we're going to tell read table that our columns are labeled in the file. And for this, all we need to do is set the logical argument header to true. The read table function considers column labels as the header for the table of data itself. And so make sure we don't confuse this with our file header that we skipped using the previous skip argument. Now at this point, with just these two arguments, skip and header, we've instructed the read table function to skip the first line containing our string, this is our header, and then consider the next line, which is the first line it's actually going to read, as the column labels for our table of data. However, before read table can actually read our column labels and subsequently the data, it needs to know what delimiter is being used or what separates each item in our data set. And so for that, we use the sep or SEP argument to specify commas since our data is comma delimited. And then the last thing we need to tell read.table is that in addition to our column labels, we do actually have row labels intermixed with the data. And instead of being a simple logical, the read table function requires us to specify which column the row names are in. And so in our case, the row names appear in the very first column. So we're going to say row.names equals 1 for the first column. And with that, we're actually ready to read our file. But before we run this code block, there are two things that we need to do. The first is we need to clean up our mess, right? We've created a temporary data file on your system, and before we exit this block, we want to make sure that that temporary file is removed. To do that, we're going to use the unlink function. Simply pass the name of our temporary file, and this will handle all the cleanup for us. And then the last thing we're going to do is print our data frame, right? We want to verify that the data we read back in is in fact the data that was in our original file. And if we look at our output, we see that we do have a data frame that has row and column labels, but unlike read lines, all the data in the columns are now integers and not strings. So this data frame is actually ready to be used in some analysis, whereas after using the readlines function, there was still a lot of work to be done after loading to convert the data into a usable form. Now, one last function that I will demonstrate here is the scan function. The scan function will read data into a vector or list, but unlike the readlines function, the scan optionally takes a list of types via the what argument. This list of types tells the scan function how the data it reads should be interpreted. So to see this, let's once again create a temporary data file and write to it our table of data. And now let's call the scan function, passing the temporary file name as the first argument. For the what argument, we're going to pass a list of 5 elements, 1 for the row names, and then 4 for the actual columns of data. Now in this example, since the scan function isn't going to return to us a data frame, we're actually going to skip both the row and column labels. And so for this first entry, I'm going to specify null to tell the scan function to skip the row names. And then for the remaining values, we're going to use an integer, so 0 will work fine, and to indicate that our data in each column will be integers as well. Now for the next argument, similar to the read tables function, we're going to specify a skip value. In the last example, skip was 1, indicating that we need to skip our header at the beginning of our file. In this case, we're not only going to skip the header, but we're also going to skip the column labels. As I said, we're not outputting a data frame, and our list that we want to output is going to contain only the data from the columns in our data file. So we skip not only the first line, but the second line as well. So skip will be 2 here. And then the last argument we're going to pass is again the separator, which just like the previous example is going to be a comma. Then of course we need to clean up, so we call unlink, and then just print our result. In the output here, we see that we received a list of length 5, one element for every column in the data file, which does include the row names that we omitted. We told the scan function to skip this by using null in the list that we passed the what argument, but the scan function will still include an entry in this list for the column, even if it skipped the reading of those values. The remaining entries in the output list are the columns of integers that appeared in the dataset. And so it may not be immediately apparent, but 159 that's in the second entry in the list is actually column A from our data file. 2610 from the third element in the list is the B column in our data file. So when using the scan function in this way, we'll actually get columns of data in each entry in the output list. Now, I want to do one more example with the scan function. While it was able to read in the data portion of our table, the read table function is far better suited for this task. So in this next example, we're going to instead use scan to read in a linear set of data, so not a table. So to start this example, we're going to do the same setup as we did for the previous 3, except instead of writing our table with the cat function, we're going to write the values 1 through 100 separated by commas. And so in this case, the format of our file is really extremely simple. And because of this, the scan call will also be much simpler. All we need to specify other than the file name is the separator, which is a comma. And of course, after that, we're going to do our normal cleanup and print. And looking at the output, we see that we get back a straightforward vector of integers. So what I hope you see is that the function you choose to read your data should really depend on the format and type of the data in your file, and maybe even the data structure that you want in the end. So the readlines function gave us back strings in the end. And for reading numeric data, perhaps that's not what you want to do. For tabular data, the read table function was able to read this in with all the labels very simply. The scan function, on the other hand, while capable of reading the table data in as numeric data, takes a bit more effort if you want to get column labels and other things. However, if you just have a vector of data in a file, the scan function can work very simply. These functions are certainly not the only ways that are available to you to read in data. The reader package in Tidyverse contains more options than I've given you here. The read Excel package can also help you to read Excel files. There are many options out there. So I've given you some links here at the bottom of the screen that can help you to find and understand not only the functions we've talked about here, but many others.